Sounds good.
Okay, we are good to go.
Great. Thanks so much. And thanks everyone for joining me. Hello. My name is Jerene Yang, and I'm one of the engineers on Cloud Spanner. Thanks everyone for joining me today, especially I see that there are folks from UK, so it's 11 o'clock. I hope this will be a good session that can put you right to sleep after this. But yes, thanks everyone. Let's move ahead. We are going to be talking about scaling Cloud Spanner today. You scale up, you scale down, end of talk. Fine. I mean, that's the summary, but there's a little bit more details. So agenda for today, we're going to talk about how to scale, how often to scale, when not to scale, auto scaling, Q&A, and whoever can count how many times I say the word scale wins a prize. Okay, so firstly, let's talk about how to scale. Before you scale, you have to make sure you have sufficient quota, right? And it is very, very important to remember that quotas are per project, per region. So for example, if you have quota for project 1, 2, 3 in US Central 1 for like 100 nodes of Cloud Spanner, that's not going to move over when you create a different project, or when you have a different region, like you want to start a Cloud Spanner instance in like Asia Northeast 1. That quota is not going to port over. You will have to request for new quota. We recommend that you do this maybe 1 day, 2 days in advance of, maybe even earlier of when you need it, because it takes up to 1 business day for the quota request to be fully processed. And you can make the quota request directly through Cloud Console. Go like there's a little search bar, type quotas, find Cloud Spanner, and then select the relative like a region or multi-region, and then your quota request will get to us, and then we'll approve it within 1 business day, and you're good to go. To actually scale, there's multiple ways. I just outlined some of the more common ways via Cloud Console. On the top right of your database, you can hit edit instance. You will see that this screenshot on the right, change the number, make sure that the sum of all of your instances under a project has to be less than your quota. That's when you will get, you'll be able to successfully scale that. And then you can also do it via a command line. It's super straightforward. I've attached that command there, or via one of our, I think 8 supported client libraries. You can do it from there too. So pretty easy introduction slide. Yeah, next one. Oh, and by the way, if you have any questions, feel free to go off mute and ask. I think that it's better if this is a more interactive session. So, we're gonna have some fun. Okay, so a very, very simplistic view of what happens when you scale. There's more details, but I was just trying to illustrate a point, right? So it's like your team hires a new person, right? So you know what happens? Let's call this new person Bobby. Okay, so Bobby comes and Bobby says, "Hello, everyone, I'm new to the team." Okay, and then what happens is people say, maybe one of your teammates, teammate A says, "Here is work, Bobby." And then, hence, note 2 in this case, hence Bobby the new work. And then maybe another teammate say, "Oh yeah, I'm also overworked. Let me split half of my work to give to Bobby." And so you will see that, for at first, let me go back a bit. That was too fast, right? So at first, you see note 3 on split 7, he was doing like, range from 14 to 19. That gets split into 2. So like, give you 17 to 19, and I'll handle 14 to 16. So when this kind of rebalancing really happens when you scale up or you scale down, or well, it's really out or in, since you're not going vertically or horizontally, but I'm using the terms a little bit interchangeably here. So there's a little bit of rebalancing happening when you scale out or scale in, up or down your instance. So that's why there is a little bit of time involved here, and that's when we talk about 2 slides later we'll talk about how often to scale, and this becomes more important there. So before I jump ahead of myself, when to scale. So a few reasons that we see our customers typically start scaling. One is when you anticipate an increase in traffic, or when the increase in traffic has already occurred. So we see this pretty frequently, especially for customers who are like, let's say you run a social media platform and you see like a spike of users once the workday is over, after 5 p.m., between 5 p.m. and 10 p.m. Then you can scale up your Cloud Spanner instance ahead of this spike so that you can handle the increase in traffic, and then you scale it down later. right? So it can be hourly, daily, weekly. We see some folks do this once a quarter when they need to write in some reports, so on and so forth, right? And then you will rely on metrics like CPU utilization to figure out when you should scale. So the ones that you want to really pay attention to is your 24-hour rolling average on the right, as well as your high priority CPU utilization. So based on whether it's a multi-region, which is 45%, I think, and or single region, which is 65. The other thing to note is also your per region. Like if you have multi-region, make sure check your other, like the regions that are part of your multi-region, right? See if there's even distribution between that, and then determine if you should scale up or not. And also important thing to note is billing is by the hour. I once got a question from a customer, hey, should I scale up and down every 2 minutes? Because I want to save money. I'm like, saving money, great. But if you scale up and down every 2 minutes, guess what? You're just like shuffling work here and there, and you're not getting any of the benefits, because in Cloud Spanner, we bill your instances by the hour. So if you get an instance, you're going to be billed by the hour, regardless of whether you use it for 1 minute, 10 minutes, or the full hour. I think that's a question.
Yes, my name is GK. I have a question. Suppose if my cluster instance has 5 nodes, and I want to scale up by another 5 nodes, and after 1 hour, can I go ahead and reduce the instance size to back to 5 in just one go, or it has to be one node by one node? Because
great question. Yeah, so I actually have a slide that covers this. So yeah, I'll be sure to address this later. And then there's a question on chat, which is rebalancing times between scale up and downs. I have a slide that covers this too. So let's hold tight. Okay, so I think great. It's just this slide. So how often should we scale, right? Scaling up, there's actually no big drawback to scaling up in one shot. Though I've seen that customers tend to be a little bit more conservative. And let's say you're going from 2,500 to 5,000 node. I see that folks tend to do it in increments of like 500 nodes or 1,000 nodes at a time. But there's really not much drawbacks, to just going up from 2,005 to 5,000. But what you want to do is give it some time. It's like, your team suddenly doubled in size, right? Now you have like 10 people doing the work instead of 5. But you need time for people to hand off the work to others. So, with every doubling of, number of nodes, you want to give it a little bit of time, buffer. So the safe time that we've seen from what our customers have been doing is about 30 minutes for every doubling. So if you're going to quadruple your size from going from 5 nodes to 20 nodes, that's times 4. Yeah, that's right. So if you're going to go from 5 nodes to 20 nodes, you might want to do it an hour before your full workload heats, right? So hopefully that answers the previous, this question, and the previous question about should you do it in stages or in like as one shot. But when you scale down, however, this is a little bit different. So when you scale down, it feels like, oh, I can scale up one shot, I should be able to scale down by one shot, right? But it's a little different here, because when you're scaling down, the number of nodes that you have, right, is suddenly halved or a third. And so the workload on each of these servers is going to be higher. And there's an additional problem that sometimes we see with some customers. It really depends on the workload, which is that we sometimes see an increase in tail latency. Imagine this, right? So someone left from your team, and then their work is being distributed. And then someone came, and this is like a partner team, and they don't know that this person has left, so they're gonna go find this person and go, hey, I have a question about a project, but that person is no longer there. This person now has to go to manager, go like, oh, so who is handling this new work now? And then they go to the new person, right? So like there's a little bit of increased latency when things get shuffled around. So and scaling down is especially susceptible to this. So if this is like the first time that you are scaling down, do it with just 10% of your instance. So let's say you want to go from 50 nodes down to 25, go from 50 to 45 first, and see for your specific workload if there's any impact. So if there's like, no tail latency at all, it can be more aggressive the next time you scale down. Try 20% and see if there's any impact. We see that some workloads tend to exhibit more of this tail latency increase and others don't. So it really depends. That's why you want to try it out with your own workload. And once you've tried it out and you realize, okay, 25% is sort of the sweet spot where I don't see much impact and it's like the minimum number of scale downs, then just stick to 25. I mean, maybe the first time you do 25, next time, you go 50, and then you're done. The other thing is to be really, aware of your CPU utilization. So for example, like the way that, we would compute this is, let's say you're going with a single region and previously your CPU was at like 35%. If you have your instance, previously you had 10 nodes, now you have 5, you're going to get around 70%. Cloud Spanner is pretty much linear scaling. So what that means is you're going to be above your recommended high priority CPU utilization. So you're gonna experience maybe a little bit more longer latency with your reads and your writes. So be aware of that and try to stay under 65% for single regions and I think 45% for multi-regions. So compute that first and make sure that you don't bust that limit after you scale down. Okay. Then I'm going to talk about a little bit about when not to scale. So 2 large categories of when you should not scale. So one is when you have hotspotting. So either moving or stationary. And let's talk about stationary hotspots, which is a slightly easier concept, which is I'm just reading and writing to one particular key, right? So you're not really using all of your all of the nodes in your instance. You're using one particular node to one particular split, and you're like doing lots and lots of requests at one key. So really, you're contending, and all of your resources is like that's your bottleneck. Adding more nodes is not going to help that, right? So don't scale in such cases. The other hotspotting use case here is moving hotspots. So for example, if you are inserting data in like a monotonically increasing pattern, so like let's say you're moving from MySQL and we're super used to just primary key ID increment, auto increment, right? Great, okay, and then I just move that directly over to Cloud Spanner and like, oh, I have no idea why Cloud Spanner doesn't support this. I'll just write it in my application logic. Now, when you do something like this, you'll end up just writing data to that same split, and that split keeps like moving when you're doing this load of data or when you're inserting data. So in that case, you also won't help by adding more nodes because once again, the work is being served by just that one split or that one node. So neither of these cases are going to benefit from a larger instance. So how should we detect this? We have this amazing new feature that we recently launched, which is called a key visualizer. I'm not the expert, but I have linked the documentation for this amazing tool. But basically what this is saying is if it's like bright white, it means you have a hotspot, right? And so if you see like one dot or something that's super, super bright, that means you have a stationary hotspot. Moving hotspots will sort of I think like you can scroll through time and stuff and you can see that hotspot moving. So things like that, you wouldn't want to scale. I think that's a question.
Yeah, I have one quick question. When the hotspot occurs, the CPU on the instance, will it be cumulative? Will it show the particular node or it's like across the whole instance itself?
Yeah, the CPU will show the entire instance. So
how do you know that the hotspotting occurs? Because whether it should be a particular split or the server, right?
Yeah, so that's why you will use the key visualizer. You will be able to identify so when you use the key visualizer, it shows you the distribution of the load across all of the keys in your key range. So then you can see like a very bright white spot that's saying that there is hotspotting happening. But yeah, you will not see individual server CPU utilization. It's going to be aggregated across your entire instance.
Okay, thank you.
Thanks. Okay, and then next question. Next point for lock contention. So for example, if most of your latency is due to waiting, so let's say like, oh, you have a transaction that's super big, touching lots of rows, it's holding the locks, and all the other transactions are just like waiting for it, not doing anything. So once again, you're not utilizing all of the resources in your instance. That's also not going to be helped by you growing the instance. So how do you detect this? Log statistics. We have a set of queries, the introspection queries that allows you to take a look at all of the top queries by wait time, log contention, things like that. So use these tools to help determine if scaling out is going to help you or not for your use case. But in general, if you see low CPU utilization and high latency, it means that scaling probably won't help. I see a question. Hello.
Yes. So in this case, do we have any like monitoring tools that give alerts if there are any hotspot happening in the instance?
I don't think we have alerts for hotspots because sometimes this is it's okay. Like it is as a product, we are not here to say, hey, customer, the way you're using our instance is completely wrong, because we don't know what exactly your use case is going to be. But you can definitely set up alerts based on metrics. I actually, I'm not super clear about this. Does anyone know? Maybe someone from the Cloud Spanner team can help in the chat about whether we can set up alerts for hotspots. And I will proceed to the next slide while someone helps you. Sorry about that. Not super, not super
that's
up to date.
That's okay.
Thank you.
Yeah. Second question, actually related with the scaling. We have some auto scaling, not really features, but like workaround to do the auto scaling, right? I mean, it's really based on the number of nodes and the storage, and based on the CPU utilization. So in this case, in the previous slide, you mentioned that we should do the scaling in bulk, right, instead of staging. So if that's the case, how is the auto scaling work? I mean, if it's only adding one node each time based on the workload, right? So
yeah, so that's a great question. So I'm going to talk auto autoscalers very soon, but for the autoscaler that is in the ecosystem that is that was developed by the I think the Cloud Spanner solution architects, that one you can set the step size. So you can actually say, how much you want to scale up or down. It's not one node at a time.
okay, all right, thanks.
Yep. Oh, there we go. Autoscalers, perfect. So all that stuff that I just mentioned, right? You can do it manually and like stare at the screen, stare at metric screen. Like, ain't nobody got time for that. So instead, what you want to do is attach a autoscaler. And the way that autoscalers work in general is just it monitors some form of a metric. In this case, mostly our CPU utilization, and then it can scale up or down. And there's a lot of things that you can tune. I think 10 plus, 20 plus parameters from what I remember. It's like a JSON struct, and you can fill in all of the details, and they involve things like how often do you want to size up? How do you want to size up? For example, linear, stepwise, or just one go. So these are actually options that you can pass in to the autoscaler. One of the open source autoscalers. And so you can actually really just customize it to however you want to do it. You can try it out. It's pretty good. And that's the first one. And then recently, actually, I knew yesterday that the DMW group has built another standalone autoscaler that it's super awesome. It's stateless. It's based on Spring Boot. And what's really nice is that we've heard from some customers that because of some security restrictions internally, they cannot use Cloud Functions or Cloud Scheduler, both of which the one that the Google Solutions architects have put together will require. So if you have this restriction, you will not be able to use that first autoscaler. You can take a look at the second autoscaler, which might work out better for you. Sorry, I saw a question on the chat. Can a given split be available on multiple nodes to allow a higher read throughput? So what happens is that, when we have a lot of work, a split can be split into further splits, and then, that gets distributed. But if you have exactly just one key, that key is on one node. You can't have that key be serviced by multiple nodes. So you can go all the way down to just one key. Okay, so this is a brief overview of the autoscaler architecture, but basically, you've got your cloud spanner instances here. There's the monitoring API that's really looking at the CPU metrics, and then based on that, we figure out how often to pull these, for the CPU stuff, and then we'll scale it as needed based on the configuration parameter that you have provided. There's a question.
Yeah, I think you mentioned about the split. The given key is not available on other nodes. It looks like it's wrong, right? There will be always split replicas. There will be,
Yeah,
it depends on the
that's correct.
configuration. And the
That
question
is
was
correct.
about that one, if that the replica is available in other nodes.
Yes, that is correct. But it can be available on so we have replicas in multiple, like let's say if you have a multi-region, then you can have replicas in other regions. But if it's like, a single region and every region would have, some number of zones, but like what I'm saying is it cannot be in multiple nodes in the same region, same zone. If that clarifies things, but yes, you can. So like if you come from like the MySQL world where you have like read replicas, and like you're moving to a multi-region in Cloud Spanner, your key can be you can read from the other regions, and you can increase your read throughput that way. So yeah, thanks so much. That's a good clarification. Okay. Let's move forward. Oh, that's it. And I have added some of the resources that I've covered there. I have written up a blog post about this, I think last year. So it's got what I talked about, but in a little bit more details and more reasoning behind it, why some things need to happen. But yeah, so feel free to click on that. And yep, we have 5 minutes to spare. Any questions? Great. Thanks everyone so much for this interactive sessions. And I think we are done. Roy, back to you.
Okay. All right. Awesome. Thank you all. And thank you, Jerene. And yes, so the recording will be available. It will take about 2 to 3 weeks before it becomes available, but we will definitely get it out there. All right. Thank you all. And I will end the recording right now.
Thank you.